Okay, I think we have everything set. So, what are you going to do, Lemos?
It's already doing the thing.
Huh?
It's already recording the thing.
Yes.
Okay,
It
let me close everything here.
is recording. But I'm not seeing your screen, by the way. Not
Wait,
yet.
no, that's. I'm just closing stuff. Close all. I'll also close this and this. Yeah, I think I'm ready now.
Okay. So, are
Okay.
you sharing on Discord something?
Yeah. So Mandelbrot set. Okay, so today we're gonna start something to attempt to make a Mandelbrot set, which is basically a recursive function that generates a fractal. The function is this, by the way. Maybe it's too small. The function is this. So the next generation of something is the previous step square plus c. C is kind of a constant in this case. And something that we want to be aware is that this sequence of numbers, they need to be bounded, right? So this cannot diverge. Because if they diverge, we're gonna have a very, very complicated problem on our hands.
Okay, can you say that in a simpler way?
Uh, Simpler than that.
Like, for instance, we are doing an iteration and we are getting results. That result cannot surpass a threshold. That would be the diverge that you call
Um,
it, right? The
that would be the
bounded that
diverge
you
that I
mean
call it.
is that is restricted to a threshold, right? Is
Uh,
that what you mean?
that's one way to do it.
No, I mean a way to put it in simpler terms.
Yeah, that's one way to do it. That's honestly because apparently there are known values of the constant that you can guarantee that the thing will converge. Uh,
But
and and what is this? What are z and c in this particular case? So they are complex numbers. So these will involve modeling if we want, right? We can use like natural numbers for it, but I think it would be more interesting to explore complex numbers in the language that you're going to do, which is OCaml in this case. So there's one piece of code that a guy made in JavaScript.
oh yeah.
For better or for worse. For
That's the
better
way
or
to say
for
it.
worse. So Magetta, love that.
Close demais.
The coding
Here,
train. Oh yeah.
yeah. So this is this guy made a very simple code in JavaScript that does this. I not necessarily understood everything because my experience with JavaScript is not that far. It's not that deep.
But everybody knew JavaScript. It was the universal language.
Well, it kind of did it.
And
Yeah,
this is the
unfortunately.
code. So ignoring the only thing that matters is this 200 by 200, which is the plane of existence of the fractal. And as far as I can tell, these two floors are iterating through all the pixels in this 200 by 200, and then we are setting them. We are creating variables and doing manipulation. This is the convergence method that the guy used. So he is basically doing an arbitrary number of iterations and calling that a convergence. And this is basically the complex number arithmetic square. So if you pick two complex numbers and the same complex number square, you're going to obtain a square minus b square to ab. And after a certain condition, we stop the loop itself. And then he is using these AAs and BBs thing to do the algorithm. So the z equals z squared plus c. And if we achieve the convergence, which is basically this if, checking if n got into max iterations, we set the background to I think this is black, and we because it was set it before as this, right? Which I don't necessarily know what is this, but I know that if we got iterations, we set it to 0. And
Wait,
then
which part you're saying?
yeah, this var bright, I think this is what colors the 2D matrix thing.
Oh, yeah.
I don't know exactly what this is doing, but I only know that this is different than 0. But if you got a
Like,
convergence, we do
he's
0.
mapping the thing. So he's mapping n, that is from like 0 to max iteration to 0 and 1.
Yeah, but n is a number, so how does that
No,
work?
no, not mapping in the sense of a collection. Mapping the sense of... I forgot, we have a name for it. But basically, if you have like 0 to 100, you could like quote unquote map that, right? To be between like 0 and 1. Do you got
Oh, you're changing you're in
the
this case
scale,
you're
right?
shrinking the scale, yeah.
Yeah, we have a specific name for that, but let's use it map because...
Anyway, so and then he goes through the pixels, and apparently he sets the color, and this is basically the entire thing. The thing that I would add to make this a little bit more interesting in the specific case of OCaml is not to cheat using normal numbers. I think we should use complex numbers. We
I
should
think it
attempt to
actually
model
would.
those.
I think it would actually be harder doing otherwise.
Not using complex numbers?
And dude, just making complex numbers, just make like A, B, like a real and a complex thing, and then you just treat them. Like if it was, otherwise you would have to be careful with the additions, the functions, casting stuff. I think it's worst.
Not sure what you mean because, well, we could mainly go like 1-to-1 in this code.
Yeah, but like, I'm saying like you cannot add an integer and a float, for example, right? And if you're handling like natural numbers in this case, what is the thing?
Yeah, he's using var A and var B, which I'm guessing
That's
are
floats,
natural.
In
I think.
JavaScript,
They're floats, sorry.
all of them are floats.
Yeah, so that's the thing. Because I want to make this z squared to be actual a square of complex numbers. So we just do this. You're just gonna pick a complex number, complex,
I'm curious
and
about
then just do
something.
this.
I know that we start the iteration with 0, right?
I think he decided to start with 0. Yes.
No, not he. Like, it's on the Wikipedia page, if I'm not mistaken, right? The iteration that you go with this function starts with 0, right? But that is the thing. So, is that a complex number? How does that work?
No, this is a complex number.
Like 0?
Yeah, the z the z 0
There
is
must
0.
be an initial case.
Because then z1 is gonna be z0 square plus
Oh,
c.
there's
Right?
an initial case, right?
Oh,
So you
okay.
should be
But
careful.
all the other iterations are complex numbers, right?
Yeah.
Oh, okay.
Maybe I'm wrong though. There is this the guy's videos which is okay. I think this video. The number of file ones are better.
Well, they are doing different things, right?
They are not. They are not actually. This is just an the explanation with implementation. But anyway, here z0 equals 0. See?
Okay.
Then basically z1 is gonna be something. Z0 equals 0, yes. And then z1 is gonna be c as far as I remember.
I think you're gonna get a copyright.
Yeah, I think we have problems with Twitch and maybe YouTube should do that. I don't know.
Anyway, yeah, this is just c. You see? So z1 equals c. So yeah, it's exactly what we said. So this z0 equals 0, and then you start from that. Something that matters is that c, the value of c changes the final image, which can produce something like this.
Wait a bit. Not sure if you are talking about the same thing, because the value of C, it will be. Wouldn't that be the complex number of like that point in the plane? So they are like values, right? I think you were talking about something else. You are talking about the like Julia set or something.
Maybe because that's one of the things that the number file videos talked about.
Because the Mandelbrot, I think like we are iterating through C, right? Also, like
As far as I remember, the number file conclusion was every single point in the 2D plane that is inside this black thing. If the value of C is one of those, the thing will converge. That's the conclusion.
yeah, that's the important part on what you said regarding if they are C, right? So we'll run the function for each C, and the C will be any point or each point in the plane, right? So will
Yeah.
not be okay.
So here's an example. So if you start with C being 1, the sequence is going to do like this, which tends to infinity. So 1 is not in this black area.
Okay.
On the other hand, for C minus 1, the sequence is 0, minus 1, 0, minus 1, which is bounded. So minus 1 belong to the set. This set.
That is also something else that maybe is worth it to explain, Lemus. What about these shades? We have the ones that don't converge, right? But also they have different colors. What does that mean?
I know what the colors mean. So the color means how it's the level of unconvergence that they have. So if it requires 200 attempts to discover that you don't converge, you're gonna put you yellow. If it requires 50 iterations to discover that you will not converge, then we put it blue. And this is how the number file people made the crazy. This is how you made super ultra colorful. So you judge how chaotic it is, basically.
So you judge the n of the function execution of a given C, right?
Yeah.
Okay.
But I think for starters, we should start trying to mimic this, but with complex numbers.
Yeah, we can do like only it converged or not for the first version. Okay, so do you want to start by modeling the complex numbers in OCaml?
Yeah.
Okay.
And the arithmetic operations.
Sure. So here we are. You create a new type. And yeah,
Signature files, man. Let's use all the stuff.
there is no point on that here.
I mean, it's just a feature.
Huh?
It's just a feature we misuse.
Like it depends, because for instance, depending on what Lemu wants, we will need like module signatures and stuff, but there is no point of doing that if we are going to use one file and like, well, you will see, man. Like I don't think we have any need for that now. But Lemus. So
Man, I'm back.
Huh?
I think I wasn't listening. Like you chopped the thing. I don't know what happened.
Oh wait.
What exactly?
No, but it was me. It was me. Pretty sure.
Oh, okay. But what I'm saying is we don't really need that now. If we feel the need, like we add it later, right? With other files and signature files. But Lemus, okay. What do you want to do? Because there are two different things, right? One thing is creating a type for like a complex number, right? And it could be abstract for the person not knowing its implementation. But you also were thinking about type classes, right? Is that because you want to use the thing with integers and complex numbers? Is that why you want the type class?
No, I want the type class to be able to do complex number 1 plus complex number 2, and the thing does it by itself using the plus.
Oh no, we don't have that.
That sucks.
Yeah, we don't actually have it.
Okay, so we can't. We're gonna have to do it by hand then. Ah, that sucks.
Wait. Say it again. What you want? You want to use the normal plus to sum complex numbers?
Yeah, and
Okay,
do
we can
power and.
Okay, we can actually do that. We can actually do that. You can
Do
define.
that with a module, I think.
Yes,
Very cursed.
exactly. No, not cursed at all. Actually,
It's cursed.
no, not at all. Like, see, you have the complex number, right?
What is a module?
What about that, Magit? What is a module?
Well, it's not the same thing as F sharp. I can say that.
That's okay.
F sharp modules are like a joke.
Wait. Let me conclude the thing. So Lemus, inside here, you can define like your operator, like in Haskell, right? Or like in F sharp.
Okay.
Do I have? I don't know. Let me just do that, right? So yeah, you can do that, right? So for a given scope, you would be able to do like complex number dot, and then inside this, the plus would be this operation. But we can also. Well, I don't care if you like it, but that's how we do it. We can also do like open, and then he will like have a limited scope, right, for the rest of the file. So he would overwrite the thing. So we can choose how to do it, but I think that's the least important part.
Okay, but now we need to define a. I think that the first step would be to define the type, right? So what is a complex number? I think it's a product type. I think it's the easiest way to think about it.
Okay.
Do you have records here, right?
Lemus, F sharp, man.
What kind of question is that then?
What the fuck?
I don't know. It's totally a different territory for me.
No. Lemus,
No,
You-
not a single bit.
you
F sharp is like
basically.
OCaml or .NET, man. It's the same
Okay,
thing.
I would create a record with a float being a real part and another one being another float being imaginary.
Okay, but what is the imaginary for you?
A float.
Also, oh,
Yeah.
so that's what you want?
It's a string of a number attached to an E.
Wait, you have
That's
something
the
wrong
imaginary
here. What do you have wrong here?
You can make that like polymorphic as well. Doesn't need to be float.
Capital
Oh,
C.
okay, thanks.
Yeah.
Okay, they actually have like good naming of stuff. I prefer that way.
I dislike that actually.
I also
Because
dislike
it reminds you of C or something?
No, I prefer like .NET style.
Yeah,
Easy.
but we can make it polymorphic.
Wait, don't you mean JavaScript style?
No, thank you.
That's the same by.
No, thank you.
What do you mean by polymorphic?
We can have imaginary numbers are only integers and or floats. That's just said like a thought, because now we are basically hard coding it to be a float, right?
Yeah, but I don't see the sense of making this polymorph to abide with ints, man. Like,
I don't see a reason not to do it, but anyway. Okay,
like,
so
for
now we have a
instance,
complex number.
Wait. If we don't have constraints here and it's polymorphic, I could just as well to get a string here.
Oh, but that's the thing. For the next question would be how to add constraints.
What about that, Mageta? What can we tell to this guy?
Wait, what was the heresy?
He wanted to have a polymorphic type here instead of float. And then I said it. So, yeah, then I asked him like, oh, so you can have a string here. Is that okay? Then he asked, oh, how do we use constraints here? What can we say to this guy?
Dude, I just think I think it's a bad incentive actually, like other languages put in a Melman, if you think about it.
Lemos, the thing is, like, Mageta will have an opinion if he likes or not, like the constraint stuff. but we kind of have a way.
Okay, good to know.
You have like a complex number module, right? And that module receives another module as parameter. And he has to implement something like, oh, number and operations on that number. So if
I know a library that does that. I can send you.
Like what? Like which one?
I think it's monadic combinators.
Oh.
Anywho, I don't think it's necessary. I also agree that we don't have a very good incentive to make this polymorphic anyway. So after the type, I think that the next thing that you should do is to define operations for this type.
Okay, so now we can do the module thing, right?
Yes.
Because we have complex number, and then it has a type T.
No monadic combinators, man. Monadic transformers. Stupid.
Oh.
Here.
Type T, right?
I think we just need to define.
Oh, that is the interesting thing already to do here, Lemos. Maybe Mageta will like this.
Beautiful to enter in a OCaml thing and see like full of MLI files. Thing that we often don't see in F# because they're useless.
So here we'll be doing the equivalent of using like abstract data types in the signature files, but in one file only, right? I forget how it set the type of this stuff. But I guess it's like
I don't remember as well.
Okay, I think it's like this, right?
I think equals
what
it's
the heck
actually
is
equal
this?
Instead of this. Yeah, you can do like equal sig and then include something else inside.
What is this thing in line 3, man?
Wait.
Oh,
like this, right?
That's yeah.
So take a look, Lemos. This is a module, right? We can try to explain better what is a module. I don't think we know enough to really explain what is a module.
Crap!
No, yeah, like module in a more like theoretical sense is really powerful. If you are not talking about using in the language, but in more abstract way. But you can think of you have modules in Haskell, man, right?
Yeah, but that's not complicated. That's just basically a way to separate your code. It appears here that it's something
I think, like,
more
making
powerful.
a parallel. I think it's a very heretical statement, but I think you can compare them to like a factory, not a factory.
No.
Like,
you can just call it a record, man, because a record can be like encoded with modules. Like,
so I think of the map. Can you show him the map?
Map?
I think you need. Yeah, just like include open a map thing. There is a make thing on the map.
Sure.
Yes, that. See, so that thing is a module that you can pass a type. See. So
no,
you can
but
do
that doesn't help on the definition of what is it.
Yeah, I'm just trying to bring it up that it can act like a, if you think as a factory, something like this, but that's not like entirely the.
Lemos, let's go this way. The simplest way to say it is basically a way to organize your code. So there you can have types inside, you can have values inside. You can think of it as a record.
The hierarchy as well, like you can include other modules, like
Yeah, that's important. You can include other modules.
Oh, here.
Inside.
I found the code. Let me see if I find it.
So you can think of like a record being a specific use case of a module, right? The difference is that in records you have like only values, right? But in modules you can have types, you can have other modules, right?
Yeah, but that exact what you just said is basically the same. You can do the same in F#, man. What's so powerful about it?
It's not quite the same.
You can define types inside modules. You can define functions inside modules and records.
Okay, what I was saying is the simplest way to think about it. It's the like most basic way and kind of the most important for the usual use case. It's basically for us to organize our code.
What is column sig on line 1?
Column sig. Okay, so this is the module, right?
Okay.
So modules here, I'm not sure, but I think they are like first class values, right? Like you can do most of things. Well, not exactly, but they are pretty like they are almost like first citizen. You cannot use them like everywhere, but you can use them as values. So this is a suppose identifier of a module, right? And these you can recognize, right? Do you see the column here? That's for type, right?
Yeah, but what is sig?
Sig is a type of a module.
Why?
Well,
That's my first question. Why would you want to type a module?
because with that we can use constraints, we can use abstract data types, we can do a bunch of cool stuff.
What is sig? What is the abbreviation for what?
Signature.
Signature.
It's basically like a specification of the thing.
Yeah, we call like
okay.
the type of a module, we call it a signature.
Okay, what is happening on line 2?
Okay, on line 2, the signature of this thing says inside it, it has a type T.
And T is the generic here, right?
Yeah, is abstract, not. Yeah.
Here, the documentation. Signatures are type specifications for structures. Signature, sig, and are collections of type specifications for values, type names, exceptions, module names, and module type names. A structure will match a signature if a structure provides definitions, implementations, for all the names specified in the signature, and possibly more. And these definitions meet the criteria, meet the type requirements given in the signature. So that's basically like you can think of a signature file, but you're basically
Like,
making that at a module level in
Yeah,
place.
I think that
You're
the
not making a
simplest-
separate file.
I think the simplest way to say is a type, man. Like it describes what your value. That's it.
Yeah, but in this case, this is not a value. This is a
No,
module.
this is the value. You want to see the value? That's the value. See? A complex number is your identifier. This is your signature, and that's your value.
Let me show an example here.
Like,
Oh wait, I copied the link.
wait, are you sharing on Discord?
I joined the session.
Oh, he joined the session.
Oh, you copied it.
Can you see here?
Look
So,
at this dude.
He's basically defining this thing, and then here he's basically pointing as a functor that is pointing to a signature. See?
I see that. The only thing that is not like my brain hurts is why the heck would anybody use the word module for this?
Huh?
That's what I don't get.
Come on, man.
What do you mean?
Yeah, module.
Because it is
Like-
a module.
Yeah, module is something that you don't use. You can even say that it's not something easy to explain, but you say that it is a module. I don't get it.
Okay, so the simplest way, and I think we should stick to it, you already know. Like, it's a place.
No, I don't know. I never seen a meaning of a module having a signature.
No, wait. Oh, what I mean is, the simplest way to explain a module, it's the one that you already know from Haskell. It's a way to organize your code. Inside it, you can have types, you can have another modules, you can have values, right? That's it. The only difference is that here, they have better support, let's say it, right? So here they are not something really apart from the language. They are actually values. They have signatures. So you know, as in C, as functions
okay, no,
are not
wait.
values.
Yeah, wait. I just want to ask. Okay, so complex number in line 1 is defining a value of the signature type T. And the value inside it is the struct from line 3 to 5?
No, not exactly. This here, it's just a name, right?
Okay.
Like when you have like let A equals 1, that's a good comparison. Like A here, the identifier, is the complex number, right? Or even better, let me do it like this. Okay, so A here, it's the identifier, it's complex number. The signature here, int, is all of this here. All of these is the signature, not only type T. So the value 1, it's that value here.
Which is written as a type on line 4.
No. This is a structure. It happens that inside that structure, we have a type. As we can have a function also. Like, See?
Okay, I see it. Okay. It's still really weird, but I see it.
And other thing to think about is, are you seeing that this value of a module is matching this type of a module?
Kind of.
Because it's not complaining, my editor, right?
That's a...
Yeah, let me just like put these like this again. Oh, actually he is complaining.
Oh,
Oh,
nice.
oh no, but he's complaining about stupid stuff like unused field, right?
Anyway, so as far as I can tell, the reason why we need a module instead of having just type complex number in the record is because we want to add functions to manipulate this thing.
Yeah, you wouldn't need a module. It's just like arguably better, right?
Okay, so what would be how can we do the only operation that we need actually is I think power. Let me just check Wikipedia again.
Let's remake an object, Nathan.
No.
Why not, man? It's so cool.
First of all, I don't know object-oriented stuff in OCaml, and we don't have a need for it.
Like, man, it's the same thing as a module in that case, but...
Okay, we need power.
Cool.
We need power
Very
and
cool.
plus and subtraction, basically. We need those operations for the complex number.
Okay. Power, sum,
And sub.
and sub. Okay.
I would actually prefer add instead of sum.
Okay.
But
agreed.
Okay, so now we need to teach it how to do all of those.
Mm-hmm.
So if you have yeah, so it's A would be a complex number. So I guess would be the type T in this case. Is that correct?
Yes. Well.
Oh, really?
Wait. Can you say that again?
Yeah, the first argument of power should be the complex number.
Let's do an interesting thing, right? Let's do the following. Module signature? Magetta, do you remember signature?
Hmm?
How we declare a type signature? Like on their own?
Good question. I think in SML it's just signature and the name, and then you put the thing.
Wait,
like
I don't
this.
think that's it. Maybe it's like module type? Oh,
Let me
module
see.
type, I guess.
Is that it? No, it doesn't seem like...
Yeah, I think
Let me see.
that's it.
Like signature. And then you can type like whatever, like ABC.
Oh, I think it's that way, Magetta. Module type.
Module type. Okay.
So let's begin by designing only the.
Oh no, I fucked up.
Let's begin by designing only the type lemos. So we have a type T, right? Like,
Okay.
we don't need to know what T is. T is a complex number. That's it. And then we have operations in it, right? So we have the add, right? That receive like A. Oh, now I need to do like this, I guess? I don't quite remember. But
Wait, do what?
oh no.
The value of the argument?
Yeah, like this, right? Oh yeah.
Oh, yeah, it needs to be specified, yeah.
So
Wait, what is val?
okay.
Val, it's like a signature. It's like a value of his module.
Oh, you're declaring a function that will appear in the next block?
Yeah. Yeah.
Okay.
So
Okay.
is that correct? Like the value add will be the type of T to T to T?
Yeah, that's correct.
Okay. All the operations, right?
No, not all of them.
Okay. So sub is the same, right?
Yeah, sub is the same.
What about power?
Power is gonna be a T, an int.
And an int. Yeah.
Oh.
Yeah. Now
Is it always an int? Are you sure?
Yeah.
we could do it, but I don't see a purpose.
Because a fraction would be
Float,
valid,
you
right?
mean?
Yeah, we could do a fraction, but I don't see a purpose on it.
Yeah, but let's just go with int, man. I don't wanna...
Yeah, it's always true, right? The case we have.
Yeah, it's always true.
Oh, so why don't we do the square instead of power?
Yeah.
Okay.
Okay, then
Yeah,
it's
that's
Chi
better.
to T, right?
Yeah.
So square. So,
I'm
okay, I
looking.
think that's it, right?
Yeah, now we need to implement those as far as I can tell.
Yeah, so let's do it. So let's actually
We
create
could
like
do this.
the module. Oh no! That's cursed, Magetta.
That's beautiful. I've been doing this all day.
What the fuck? Okay, so it will fail for now, right? But let's match the type. For now, we do have a type T. That's our concrete type T, right? And now we need to implement the operations. So let me get this right. So, okay, how do we implement that ones?
Can you pattern match in here?
Dude, if you cannot pattern match in a pattern matching language, then that would be very.
No, I don't know if you
Lemos,
can do it inside a struct inside a module. That's my
Lemos,
question.
come on. You literally can assume that is 99% equals to F sharp.
Okay, so the first thing that you should do is pattern match A and B, man.
Okay, like in line here you want?
Yeah.
Okay, what parts do you want? Both?
Both.
Okay, I'm not sure if that should be really pretty, man. How do I call that? How do I call this? Like
R1, R2, I1, I2.
wait a bit. So imaginary.
I1.
Okay.
And then the same thing with B, but with 2. And then the result of this is basically wrapping the sum.
Like variables like this.
Uh,
Numbers and variables.
That's actually sad. And by the way, I don't have that in that tiny language. Like it doesn't allow have numbers in identifiers, man.
Blessed.
So oh, I forgot. We have floats, right?
Yeah.
So we have a special thing here. So we don't have a plus for floats.
What?
Yeah, we
Yes,
use
you have
this.
the plus dot.
Why?
Because we don't have a Hoc polymorphism.
Ah, I wanna cry, man.
Why?
That's terrible news, man.
It is
Ah,
not.
not really. Not
Yeah,
really.
really,
Because
yeah, really.
with no, it's
That's
not because
much better,
with,
actually.
with that way you know that if you're looking at the code, you know that those things are floats.
You're just trying to justify making the language more verbose by adding new symbols.
Yes, I am. Yes,
It depends.
and
Like
that's a good thing.
Haskell, like Haskell doesn't have a problem because Haskell he will just say that the thing has the constraint of have this type class, right? But
Yeah.
F sharp has a problem because in F sharp, if you do that, it could be inter or float, but he will assume the first, if I'm not mistaken.
Yeah, but in F sharp, I think they cast to the .NET modules. That's why you don't have that problem. Like it's the same thing for
No,
for
I
example,
mean
printing.
problem regarding you. It could be two different things you're looking at, but the inference will just take one.
The
Okay,
inference
okay.
will
Just
take one.
copy this add.
Okay, yes, okay. I see
Copy
what you
this
mean.
add the entire line and just change the name to sub and change the plus to minus.
Okay.
Oh, man.
Dot.
Okay.
Beautiful.
Okay. Square. Just remove the. You need to pattern match and remove the B in the square.
What do you mean by oh yeah, remove the B.
Yeah. Now there is an expression that that basically describes how to do square. So the real part will be real square. So can you do square with floats?
I'm not sure.
Sure, let's see. Does this
Okay.
exist?
No, you don't need. We don't need dots. We don't have witins, I guess. Oh, wait, but we have a problem
minus.
Apparently you do.
here. Oh yeah, no. This is a dot 0. Like both needs to be floats. And
Minus in the same real part. So minus imaginary square. That's going to be the final result of the real part.
Okay, minus
imaginary square.
I think we might have a function for square.
I think it's a distance, right? You need parentheses.
How
Square
nice.
root. We don't have square.
Yeah,
We only have the operator.
Okay,
oh,
and then
wait. You don't need those parentheses, man. You do not
Nope.
need. No.
Oh, right.
Precedence,
I know
right?
what you mean. Yeah.
Yeah, we have precedence.
Yeah.
Okay, and now I have a question though. In the beginning of line 16, are you guys pattern matching using the names of the fields? Can you do that?
Wait, what? 16?
Yeah, 16. You're pattern matching, but you are not providing names for
I
the
think
things.
that's calling like pruning. It's the same as this.
Oh, okay.
See?
I actually don't like that, but that's fine.
What?
Yeah, because I purposely chose the names to be to be fields in my type. I don't want them to be names of pattern matching things. But anyway.
But man, if you chose the names to be
Right,
fields
this is
here,
better.
that's why they are the best names.
That's how you're gonna get confused. But anyway.
No, but okay.
The imaginary part.
Matter.
I already got confused. You also can do this in Haskell. In my experience, that's a terrible choice. But anyway,
What?
you also have pruning there.
By the way, you can do the same constructing the records also, but I think you know that.
Okay, the imaginary part is gonna be 2 times real times imaginary.
Go
Wait,
on
the
like
imaginary part is
2 times
2
times real
times the real part
times the imaginary part.
Imaginary part. Okay.
Yeah, that's
just that.
okay. That's a square. Yes, and then now we're done. Okay, so
yeah.
now we have add,
but
sub, and
Where
square.
does this come from? Let me just think here.
Do you see any problem
Like
with
this-
this implementation? Oh wait, the parentheses? Wait, what the fuck? Why- Why does he add?
Let's see.
Like when I
Uh,
save, he adds that.
Oh, when you save it adds, right?
What the f-
I don't know.
What?
I think it's just like it thinks it easier to read, whatever.
Huh.
I hate linting anyway. It's evil.
That's
Okay, so
formatting.
where this solution came from is basically
formatting.
doing a plus bi times a plus bi, complex number multiplication. And then you do the distribution, and then you sum them up. You're gonna finish with
We
this.
know for sure that the square is true because of the definition, right? Of the I.
Yes.
Okay. Lemus, but do you see any problem with this implementation?
Hard to tell.
So you are seeing the signature, right?
Yes.
So the signature is the thing I said regarding being abstract. Because here, on the signature of a module, we could literally use the same here. Okay, here. And it still runs, right? But if we omit here, it will be abstract. What it means that the outsider will not know the implementation of T.
That's
So
interesting.
how can I create T if I don't know its representation? That's the thing. I cannot. I cannot
Yeah.
create a complex numbers of now. As of now.
I think you can,
No.
but if you create like a constructor inside the struct.
Huh? Constructor inside the struct.
Yeah, like create complex. No. You make a function called create
Oh,
complex. And
yeah,
then
yeah,
it passes
yeah.
two floats.
That's the solution, yes.
But that's very, very object-oriented crap, man.
No, not at all. Do you know why? Because that way you guarantee a bunch of stuff. So suppose I'm creating the module with the type of the natural numbers. You see? So
That's fine.
I can guarantee that on the create that will receive an int, I can assert the value of it. I will never be able to create 1 with -1. Do you know why this is good? Because suppose you create a type named email, right? And email is not the same as a string. Do you agree with me?
Yes.
Why?
Because usually you need to have like special symbol, .com, stuff like that.
It has constraints, right? But
yeah, that's the thing. You cannot add constraints
An
into the
email
type.
has a
no,
different
that's the constraint.
constraint.
Like, it's only
Ah.
possible to create via this function. And you don't know what it is outside. It's just a mail. You see? So that's another kind of constraint, not the one that you're talking about. That's constraint on the value.
Yeah,
That's-
I still don't see why this is better than having constraints on the record itself.
no, they are not the same thing, Ramos. They are not the same thing.
They are not the same.
No. You are talking about constraint on types, if I'm not mistaken.
I think you can do both.
No,
I never experimented in Haskell.
no, you probably can do both. I'm just saying that this here that we are seeing is constraint on values. And
Okay, so the way that you do constraint on values in OCaml is by not exporting the type itself, so that it's hidden, but you provide a function that allows the developer to create a thing.
yeah, because that way it's impossible for you to have an invalid email type. Because if it's a type email, it is correct by construction. And I think that Mageta loves this phrase. Correct by construction.
Construction, yes.
And the other things is regarding the operations, right? If I define the operations here on complex numbers, I can just deal with them in the way I want. I can even do the operators, as you said. And this also has the great benefit of it. Because if complex numbers cannot be in an invalid state, because we are like controlling how we are creating, the operations in it also will never do something invalid, because we will check on them. So if this was a type of like reais, like a monetary value, you would never be able to have like negative values or do a bunch of crazy operations, because on create you would check, on the operations you would check. You would not be able to do like crazy operations with money. So man, abstract types, they are great.
Okay.
So what about create?
What about create? Okay, so you pass 2 floats to it, and we just wrap those in. Do we have eta reduction of some sort? Because this seems
We
a
have
very
a beta reduction.
Not for
Yeah, it's-
records.
Oh, that sucks.
He
Okay.
wants to do like what's the name? Point free style.
Yeah, I think it's also called
Fixed
point
point
free.
Yeah, he wants for not to have the arguments here, you know.
Yeah.
But do you have these for records in Haskell?
Yeah, because we in Haskell we need to provide a name, a constructor for the record. You cannot just put curly braces. in one of the-
Wait, and the constructor of the complex number, it's like a function from all the fields, the type of the fields.
I never explicitly asked the
Well,
type
if
system
it's
that.
not
You can try.
these, there is no way you do eta reduction, because these will need to have this type for not to appear here, the parameters.
No, anyway, I just asked. I can try that later, but I'm
Okay.
pretty sure you can.
Yeah, we only need to declare here, right? Because that's something we wanted exposed. Oh, the other thing is, do you know in F# how we use private? Here we just
Private.
yeah, private. Here we just omit it in the in the type of the module. Then he will not show it to an outsider.
Oh, okay, makes sense.
So create, it receives a
By the
form.
way, is this a default project in OCaml that you made from scratch?
No, that's a personal template that I have.
Okay.
And by the way, this template, he doesn't let you create utils dot something. He deletes your file.
Oh,
I
Very
don't know.
not this
I don't
stuff.
know why you are laughing, man. I have no idea.
Because it's exactly like you, but it's ridiculous. But
no,
anyway,
it's so sane, man.
no, I'm not gonna go through the discussion
It's
again.
like-
I think
there's a whole chapter in that book, like from the structure design, like the guy renting on like utilities.
Oh, wait, what is the name of the thing?
Structure design, Edward Jordan.
Oh,
It's a very good book. by the way.
I don't know this guy, but already consider him a lot.
Yeah, that guy's a Chad.
Just remember to clean this up before committing, Nathan. Because I
Oh,
don't think we
well.
need all of those.
We actually do.
All of
I don't
those,
think
what do you
so.
mean?
Yeah, this should not take more than 2 files to do.
What about Haskell?
Wait,
Did you
wait,
saw
what
We
are you
your?
need
talking
3
about?
files in Haskell.
No. All the other files that you needed in the project.
No, that was configuration.
No,
Is this
no.
all configuration?
Yeah, I only have main.ml. That's my only
Wait,
source code.
you're, you're looking at this template, right?
Mm. This here is regarding package manager. This here is regarding also the dependency manager, but is a different one. This is regarding the build system. This is regarding the formatting. This is Git. This is regarding formatting on files in general.
Or if you want to go ooga booga, you can do anything in like one file and just like implement all the functions by yourself and compile.
Yeah, but that's like that's
Ooga booga.
C without make. That's really Yuga Buga.
Oh,
Okay,
it's
so
C but safe.
I think that we are now on the point that we should create the main function of that does iterations.
Okay. Can
But I
you
think
say what is the interface of that function?
yeah, but there's a no. I think wait, we need to define another thing also. We need to define the plane of existence of the complex numbers, if that makes sense.
Okay, it does.
Because we kind of need to accumulate those in some sense. Because at each
What?
iteration, we need to save.
Wait. What do you mean by accumulate those?
At each iteration, the final value of the quote-unquote conversions, we need to put that on some sort of a storage.
Wait.
Because we need to
Repeat
save them
again,
to
please.
print it later. Yeah, so if you go to the... I'm gonna send in the...
No,
I'm gonna...
just repeat it first. Like,
Okay, so if you remember the JavaScript guy, so he had
you have a plane. In our case, is the screen that we will print. Like it's
exactly,
like a
but
map of pixels, right?
yeah, but do
A
you agree that
matrix.
after the computation is done, the guy is basically saving the result if it converged or not in the plane of the
Yeah, but
colors?
that's only a map on a matrix, right?
Yeah, so we need the matrix.
Well, I'm not sure if we have like standard matrix. I don't think we do. Do you know about that, Magetta?
He's muted, so I think he left. So matrix OCaml.
I don't think we have one on the standard library, but we can.
We have array.
Yeah, of course we have array, but I mean, we can use. Oh, we can do more modeling, right?
What?
What
What happened?
he was asking regarding if we have matrix in the std library of OCaml. We don't. We could
I
use a
don't think
library,
so.
or we can implement our own with the same type of modeling. And I think I will separate this in another file as Magetta suggested.
Yeah, so what we need to do now is to model where we're gonna store the values.
Okay, so do you want to create a matrix? Like, is that it?
I don't know if I want to do that because the last time around we did that in Lattice, that was a pain.
No. Don't even compare.
What?
Don't
I
even
heard
begin.
letters. No, man, no. I don't want you to repeat that, please. I'm never doing that again, man.
Oh,
And I suspect, by the way, that in fourth it's the same. But it's like with postfix combination notation.
Anyway, so the matter of the fact
so
is
let's start by the type of the thing, man. Like module type is equal to this, and that's a type T, right? Matrix.T. And but this is a type constructor, right? Because well, yeah. So see, we have the type matrix T, and it's a generic type. It has like one argument in it, because it can be a matrix of. Oh, Magetta, we might need functors here.
Wait, just
no,
a
we do
second.
need functors here, man. What are you talking about?
We are not talking about the same thing. I mean, we might need a function from module to module.
Oh, the name of this in here is functor?
Yeah, it's literally.
That's a really, really bad name, man. But okay. Everybody else is talking about functors, and only the OCaml guys are talking about something else.
No, maybe they are not the same, but this functor here, module to module, it's probably an instance of
What do you mean? What do you mean it's a different thing, man? It's the same thing.
No, not the same
A
thing.
module is
it's
wrapping types. A functor is mapping types. It's like wrapping. It's a wrapper over a type, implementing functions.
No, wait. What we mean is the function of module to module is called functor here, and he's saying a bad name. But the thing is, it's a case of mathematical function.
But that's a
like,
but then
for example,
I asked Nathan, what is a functor here? And he said it's a function that goes from a module to a module. That's not what functor does.
This. No, it's no, man. It's the same thing in the end. Like, think of this. What is this?
It is an optional type.
Which is a functor.
The option type can actually implement the fmap, which is the contract to have to be a functor.
Which you make in the same way as a module. So what Nata is talking about is the same thing.
No, it's not, because when you're talking about functors, you're talking about lifting. We're not talking about modules to modules.
But it is lifting. It's lifting one module to another.
Like, no, let's show the map type. The map type is a good example.
One module to another.
Module wraps a type. So it's the same thing as a functor.
What is the simple function that you are lifting?
Okay, let's wait Nathan's example.
Like, we have this here. So we have the string, right?
Yeah,
and we have the map. And then we create that, like, map string.
Well, yeah, but I'm not seeing the functor in here.
I'm not sure regarding functors, but you can see that is basically the same as the type constructor.
Yeah, you don't have the fmap there in this case. Actually, I think you do because of the map, but you can define that anyway, which is the lifting.
Yeah, no, but I'm having a hard time to understand which function is being lifted.
Wait, you mean foregoing to a map string of a map like int, for instance? That's what you want?
Let's let it, yeah.
Well, you could implement that.
No, but I'm having a hard time to understand which function in here is being lifted. That's my question.
Well, a string is being lifted, right? To be a map.
Okay, so you want an example?
Yeah.
Let's suppose that you have an option of an int, okay? And you want to have, but you want to have an option of a string, right?
Okay.
Let's suppose that we have the show function.
You want to map, I don't know, 1 to, let's just make it concrete. This.
Yeah. So the function that I would be lifting would be a function that picks an integer and transforms it to a string. And this is a pure function. It does not involve any sort of wrappers.
Oh, I think I got what you mean now.
And then the type, what we want is, okay, picks this pure function that only manipulates pure values and lift them to the plane of structures, which would be, I don't know, an option in this case.
Hang on. Oh, man. Hello?
Hello?
Yeah, I can hear you.
Okay, it was fading my mic. No, not my mic, my headphones.
Okay, so at which part I stopped?
Your voice, you're not lifting, blah, 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 and Nathan said, yeah,
okay. Yeah, okay, so what do you agree that what we want to do is to lift this function that picks an int and transforms to a string? Very pure.
So you want to make a function that doesn't know about the option, right? It should work on an option, in a list, whatever.
What we want to do is, this is a function that picks an int. Put the type signature there. So int, arrow, string, right?
Yeah.
What we want to do is to pick this and lift it to option int, to option string.
Okay, so lift. Let's not call it lift, like converts, whatever. Okay. So the types of it are what?
A to B.
Okay, let's just make it like this. X, which is A, whatever.
Yeah. And we also have a Y, I don't know.
Y, oh man, I can't see my keyboard. I feel dumb.
Okay.
B, okay.
And then what you want to do is to pick this pure function A to B and transform it to a function that goes from option A to option B.
So, okay, like this function receive. This is stupid. The signature is like this, right? That's wrong then.
Yes, now this is better.
We don't care about the implementation. Let's just do a fail with.
Yeah, no, but the final result should be option A to option B. and then
not on this function, right? Because that will be the f map.
no, what I'm describing is the f map. This is what I mean by lifting. Is when you pick a function that goes from n to b,
Which
and
is
you
this
return,
function? That's what I'm thinking.
Okay.
and then you return an option A to option B.
Let me see, man. We can think about like this. Let's do this. That is simple, right? We have like a string of int, and if we have like a matrix of ints, can we transform this into a matrix of strings by doing a map and like, well, by lifting this function?
Yes,
I'm not sure. I'm not sure.
No, but that's what I understand by a functor. That's what I was talking about.
I'm not completely sure. I would have to think more about. Maybe if we pass like two functors and then these. I don't know. I don't know.
But anyway, so the
My point
functor
is like you're gonna be, you can still make a function that will convert the type that is wrapped in the module, right? So in this
that
sense,
would
it's not-
act as a functor then.
yeah. So that's what I'm saying. Like I think it's on that it's the same thing.
Yeah, in that sense, yes. Okay, so
Folks, I'm gonna have dinner. I'll be back in like 15 minutes or so.
okay, so what we need to do here, Nathan, is to answer your question, right? So what we want to do is to pick a matrix of floats, and we just want to map it to be a matrix of complex numbers. That's what we want to do.
Is that the only operation that you want, map on the matrix? No, we need more also. We need how to create a matrix, for instance.
Okay, that's
But
also true. We
let's
also need to
start
be able
with-
to create one.
With map, right? Like our favorite
Yeah.
operation. So,
No, I like map because it's the f map of list. I don't like the map in JavaScript.
oh, that's what you're talking about?
Yeah, man. Of
Oh,
course.
it's
What are you thinking?
it's basically the same thing, but more powerful because you don't have types.
You can think it like that. I just see chaos.
Okay. It is pretty messed up, yeah. But wait, why is it not... Oh, okay.
Wait, this is not correct.
Oh,
that's
okay,
interesting.
okay.
No,
These,
but
right?
this is also not correct because now you need to define how I'm going to transform A to B. You need to pass this function as well.
Oh, okay. I forgot about that. So,
And this is basically the implementation of fmap.
so let's see.
I miss type classes, man. Okay, so now it's perfect. Can you see that we are lifting?
Wait. No, yeah. I got what you mean.
Okay. So this is what we want. We want to map it. So we want to basically iterate through all the matrix and apply the function A to B to all the elements.
Oh, whoa. That is something nice, I guess. Well, it depends. But the thing is, do you agree that to create a data structure from other data structure, we have like... well, if you want to create a matrix, we could create either passing a list or an array, like in theory. Do you agree with that?
Yeah.
So that's a nice thing. We can do something like from like array, you see? And then that's the creation that accepts an array to create the thing. But we prefer the list, right?
Yeah, but that would suck because we would have to do arithmetic stuff.
Huh? No, wait. I'm talking about the creation function. We will pass something.
But I'm also talking about that. So
No,
if you have a list of 9 elements and you want to have a matrix of 3 by 3, how you would do it?
No. That's not the thing, man. You could do it like if you want to create a matrix, right? I think that's how they did it in Haskell. I don't quite remember.
No, but this is not a list. This is a list of lists.
No, yeah, but what I mean is you could receive these as argument. I don't
from
mean...
lists, not from list. Okay.
Oh, it depends. Like, actually, you are receiving one list, right? It happens that inside you have other lists.
It happens that inside.
It's actually a list from list of list, yeah. But what I mean is that would be like, do you agree that that would be a nice interface to create a matrix from that?
Yes, I would.
So okay, so from lists or lists, right?
From lists, yeah, I would do it like in that way.
Okay. So I think that's it.
Okay. We also need to create.
Right?
Oh, from lists we're gonna create it like this. Okay.
I don't think we need anything else, do we?
I don't know.
We might need something. Like, if we want to print this in some way, we will need some kind of iter, right? Like, what I mean is, we pass a function, we pass the matrix, and we receive unit as result. Because suppose that this one... Wait. Yeah. Suppose that this one...
you cannot derive show. You need to implement your own print.
Yeah. We
okay,
do.
that sucks.
But no, actually we can, but only with extensions of the language. They are called like pipx. But I don't want to go into that right now, because I don't really know that well. But what I'm talking is not regarding show, but suppose we want to iterate over the matrix to render in the screen, right? So
yeah.
you would need the iter operation, something that it goes from like A to unit, right? And then it receives the matrix, and then it returns only one unit. So it's like a effect on a matrix. What's the name of that in Haskell?
IO.
Huh?
Yeah, the effect in Haskell would be modeled by IO.
No, no. I mean, what is the function that you do an operation, you pass an operation that results in IO, right? So what I mean is, what is the type of...
Oh, I think you're talking about the map M.
Is that a map to IO?
Yeah.
Oh, okay. So yeah, that's... So let's call it iter.
I think I used that thing once.
Yeah, I think that's his type, man. Yes. Yeah, I'm pretty sure. So, are we good? Types-wise?
Yeah, types-wise we are good.
Okay, so let's create an actual implementation for that. And how do you want to implement that representation-wise? Arrays of arrays?
I don't know. It kind of... I think maybe this being polymorphic is pretty good because we can change it later. If this isn't too slow, let's use vectors.
No. Not being polymorphic, being abstract.
Not being polymorphic.
Being polymorphic, it says that it will be a matrix of ints, of strings, doesn't matter. But we hiding the implementation is being abstract.
Like, I would also abstract the wrapper.
The wrapper?
Instead of being an array or in a list or a vector, I would make it... that would require constraints again.
Oh, wait. What do you mean by wrapper? What is the wrapper for you?
Because then we are wrapping the A values with something. In this particular case, we are going to use array. You're suggesting about using arrays.
Yeah, that's what I'm saying is abstract. And why do I say that? Because of this. Look at that. Array, I think it's like this, I'm not sure. But you see, here I have the type array, but the signature is only A of T. So the user doesn't know. I can change that later to list if I want to. That's being abstract. Like I'm hiding the implementation.
Yeah, but you're gonna have to change in all the places. That's what sucks.
What do you mean, man?
Like, if you could just put something like BB instead of array, then the instantiation of the matrix would define which wrapper representation would be using.
Oh.
That would be great.
Okay, you want to select the implementation of a...
Not select necessarily, but define an arbitrary type that has some properties. For instance, the list, the vector, and the array, they are different, but they all have the property of, I don't know how you would call it, but
We can actually do that. I don't know why we would. I don't think there is a
performance.
necessity of that.
Just performance.
No. The performance is here. Like if you have an abstract type, you do implementation, and you can always improve on that without breaking your API, because the user doesn't need to know that you change it to another data structure to get more performance out of it. But what you said, we can do with, like, let's call it OCaml functors. You could receive a module that implements some operations. That would be our constraint, you know? And then we use that we received it instead of the array here. See?
Okay.
But I don't think there is a point on that, on this case.
I don't know. For me, I would do it just because if I want to change it later, I don't have to change much of an implementation, but anyway.
So let's see. The type, I think the type's correct, but yeah.
Yeah, the type is fine.
So we also need the map, right?
Yeah. Do we have maps on arrays, right?
Yeah.
Nice.
So map of F.
I think we're gonna have to use yeah, map on map, right? We're gonna have to map twice. Okay.
Yeah. Here we don't have a problem. We will only have problems really with lists. Well, with from lists, because here we need to check the length.
I would
right?
do from oh, that's true.
No, but that's the part of doing the validation here. But all the rest is like, right? Just really easy. We can just do like.
Okay, map the matrix.
Array dot map I. Oh, wait. Do we need the indexes?
No.
We don't, right? Why?
We don't.
Wait, Lemons. The matrix that we want, they are indexes on the plane, right? But here they will be like the value of the matrix instead of his indexes.
Yeah. Which is actually what matters in this case.
Yeah, that's so weird. You know why? Because
no.
Yeah, it is weird because we could literally have a matrix of units and then use the indices of the matrix. You see?
Use the indexes of the units to what?
As the coordinates on the plane.
But we will do that later.
No. That's a different thing. You see, you want a matrix with all the complex numbers, right? That is how you are thinking, right? But the complex numbers are indices of a plane. So the plane could be a matrix of units, and the coordinates, aka complex numbers, would be like the indices of a matrix of any type. You see?
So, but then we will not be mapping the entire matrix, right? We would just be changing locally a specific complex number?
No. What matters is the value of the matrix would mean nothing. We would care only about the indices of it.
No.
But it's pretty weird.
The value of the matrix matters, man.
No. You see why? Because if I do a matrix of units, like the useless type, then we can do a map I, right? And the I will give me the coordinates of that cell in the matrix. Do you agree with that?
It would provide us the index, yes.
Yes. So if the like MN matrix, it's like the size of our plane, the indices would be the complex numbers. So I don't care about the unit.
Oh, but there's a no, wait. I think there's a problem there. No, I think there's a problem there because we care about two things. We care about the position of a given thing inside the plane, and we actually care about the value that it has. We care about both.
Oh wait, what is it? The value then?
The value is the color.
Huh?
Yeah, don't you remember?
Oh, wait. No,
The
no,
complex
no,
number
wait.
is the complex number just adjusts where we're gonna paint.
No, wait. Maybe you are confusing them. Man, if I have the matrix of units and I map in with the indices, I could no, actually it would be like iter I. So we could use iter I. Why is that? Because if that's a matrix of units, I could go to each of the units and then render that on that coordinate. And what would be the complex number on that coordinate? Would be the coordinate itself. Because
But we don't want the complex number to be a value, man.
huh?
The complex number functionality is only a coordinate.
No, yeah, that's what I said.
Yeah, but we care about the content that this coordinate is mapping. We care.
We don't, because render is a function that doesn't return a matrix. Render does an effect like an IO.
Wait. I'm confused now because you're talking.
What I'm
What's
saying
the purpose
is
of this matrix then? I'm confused.
yeah, I don't know. I actually don't know. I don't think
No, the purpose of the matrix is to put the correct colors in the matrix. For later, we map the matrix to something renderable.
Wait. No, that's the thing. We don't need a matrix with the colors.
We don't?
No.
Why?
Because I can get... That's the phrase. With a matrix of units, I can render your complex numbers with colors. How can I do it? I can do a iter I, you see. And
That's fine.
for iter I have a coordinate. That coordinate is my complex number. So I can render on the screen on like the coordinate that I am with the complex number that is also the coordinate that I am. And
I still don't understand.
Which part?
Like, I still see a purpose of the matrix. The matrix is to accumulate the values that the colors will be when we finally render the thing.
But do you agree that we can go from a matrix to the render thing?
I agree.
So what is the point of mapping that to colors to then rendering?
Because we are separating in 2 steps. So if you have a matrix, when you're doing the algorithm, you just update the matrix across the algorithm. The algorithm is basically the loop that does iterations. And then when you have when the matrix is fulfilled with all the colors that should be, then what we need to do is just to call a function that picks a matrix and produces an IO.
Man, that sounds like bullshit and is especially inefficient. You are going to the matrix twice.
I'm going to the matrix twice. You would go directly to the rendering. That sounds bad.
Course.
That sounds really bad.
No, not really. We can
You are mixing the visuals with the logic of the thing. That sounds really bad.
No, it's not the same, man. Take a look on that. Like, basically, we have a render function, right? So a render function. It would receive like coordinate, right? Let's not say if it's a complex number or not. Let's just call coordinate for now. Okay. And then it does like unit, right? Do you agree that this is like a render? Oh wait, no. Oh wait, just a second. Actually we want coordinate and color, right?
Yeah, it's still not yet, but it's better now.
What do you think it's missing here on render?
We are printing with a color, a coordinate on what?
No, this is render pixel. This
where?
On the screen. Well, it actually doesn't matter. Anything. It could be a file, it could be a screen. Like it's rendering somewhere on the terminal. So now do you agree that this does render a pixel with a specific color?
No, for me, you are not saying to me where.
I don't need to.
No, do you remember HVita? Do you remember the approach that we use in HVita? I'm just replicating the same approach, man.
Oh, wait, so... Wait a bit...
In HVita, we created a matrix as intermediary representation exactly because to not have this problem.
No, man, I will explain to you. But that's the thing. Take a look on this. We want... That's my take. We want a rendering pixel on something, right? We have multiple of those. You agree? So now, do you think it's correct? They are not generic. They are rendering in a specific place. We are not passing that as argument because they are fixed inside. So, do you agree with those types?
I'm fine with them.
Okay.
I still prefer having intermediary representation. Don't see a point on mixing those, but if you really want to skip a step, that's fine.
So, okay. So, now... do you agree that using a matrix, like a unit matrix, we can, or better, matrix.t, do you agree with me having a unit matrix? I can use iteri on it and render the thing. I can on iteri get the coordinates, calculate the color, and then pass to this. So inside of iteri, I would pass an anonymous function that would calculate the complex number, well, the color with the complex number, and then would call that. Do you agree that I can do that?
The coordinate is not enough to have the color, by the way.
Okay, let's do the following.
No, but I see your point. I think the matrix loses its purpose.
Yeah, I also think the same. I think we can literally use the for loop because we just need the coordinates, man.
No, the coordinates are not enough to get the color.
They are, because they are the complex number themselves.
No, but the complex numbers do not determine the color. The color is determined by how your level of conversion.
No. Now you are bullshitting, man. Because
no, this is exactly what I said in the beginning, man.
No. If the coordinates are the complex number and the complex number determine the threshold and not the threshold, but when converted and when converges determines the color, then the coordinate implies on the color.
No, but the coordinate may not means that it converged. That's the thing. Oh. I think we need to take a look again in the JavaScript code.
No, wait. Just think about this. This is not a function. I will use this other type of arrow to signalize that, or maybe this one that is even. Oh, just this. So we have coordinate, and that goes to a complex number, and that goes to a color, right? So we have coordinates on a plane, right? Do you agree with that?
Yes.
We can say that is a complex number, right?
Also yes.
And the complex number we can run to a function that will determine, like it receives the, well, let me do the type here. It receives the complex number and it returns the color. Do you agree that we can do this function?
Yes.
So that's it. So the coordinate determines the color. Why wouldn't?
Because it's not exactly the coordinate, it's the function f. Function f is the one that determines that.
What I mean is, if we have the coordinates, we can get in the color, because we can transform that in complex, we can run a function through it, the function will return the n, we map the n to a color, and then we render
Okay, I will agree with you, but I would just say that you are in the way that you phrase it, you are kind of misleading. That's what I want to say.
Maybe I'm simplifying. Not being.
No, you're changing the meaning. You're changing the meaning.
Not really.
The color is determined by the level of convergence. That's it.
What I'm saying is that, like, if A means that B and B means that C, then A means that C, man. Like, what I mean is, if we have all those steps, then we also have this step.
Coordinate to a color. Again, I think you are changing the meaning, and that does not portray the idea. But if you want to see it like that, you can.
Okay, but are we going to use the matrix then? Because I think a for would be more fit to that.
A for? What do you mean?
Yeah, like a for inside the for, because we don't need the value.
Wait, we're gonna do a for inside a for? That's so ugly, man.
That's like better than the matrix.
The language is also imperative, by the way.
Yeah, that's good thing.
Okay, I would prefer recursion, but anyhow.
Wait. Well, we can do with recursion?
Yeah, for loops are recursion.
No, I would say it's the opposite, but...
No. It is the first. For loops is recursion.
Well, if you're talking about computers and not abstract math, then it's the opposite. But man, that's the thing.
For a moment, I thought we were gonna really argue about that.
No, I think it's just. But man, like for like or recursion, I think recursion is.
Doesn't matter, man. Let's do one, then we can change later if it's garbage.
Okay. So what is the size of your plane?
Let's shoot 200 by 200, exactly as the guy did.
Okay. 200. Then we can do. I don't know how to write a for. Do you know, Magit?
Wait, for E, in, and then you do the range like a sequence.
That's not F sharp. We don't have ranges here.
No, yes, but you can do like a sequence of numbers.
Don't we have like up to?
No, like like an array, man, like a list or something.
Oh wait, we can only. No, wait. You are saying that this for in is to iterate on a collection, like getting the values of it to I?
Yeah, I think it does.
That's not what we want, and that would be really weird. Because that's...
You want to take in a range, like a number, right?
No. What I want is, I want for I, like...
You can make a function range that generates the range.
No, man. What I want is the plain for, like in C, but...
Oh, okay.
See? Let's see. For OCaml.
It's actually funny that we're looking how to make a for loop, because
who would use that, man? Like, we usually don't have these use case.
Yeah. Oh, it's a 1 for E equals 1.
Wait,
2,
for what?
And do. Like, where do you want to start equals that. Like,
wait, for 0?
No. E equals 0. And then you do 2. And then the number, do.
Oh.
And then, in the end, you need done.
Oh, yeah. By the way, it helps a lot, this done here, man. To not get, like... F sharp doesn't have, right? So we have indentation and such.
Yeah, you can add it, but it just ignores.
Just one thing, man. Is that actually working? Wait.
I think double semicolon, right?
No, not really.
Another thing, you can do a for out of nowhere.
It's like an expression that returns unity, if I'm not mistaken.
But how do you call this?
You need that.
Huh?
How you call this for?
A for loop?
No. How are you gonna call it, like in a REPL?
Don't know what you mean. We can put inside the function and call the function.
Yeah, that's exactly my question. So how do you call it? With a function, giving it a name, okay.
But what do we have wrong here, man? Like,
don't we need like in here?
Cannot be. No, not on the top level.
Yeah, on the top level you don't need that, right?
And we also don't need this double column. That's only for the REPL. So I think maybe the for.
Let's make a oh, kill me.
Is that oh wait. Is it because of let? Yeah, this.
Oh, indentation.
Oh, okay. We cannot just throw a unit anywhere.
That's
okay.
exact. No, but that was exactly my question. How can you throw a 4 out of nowhere? That was my first question.
No. The problem is not the
we were
for.
doing ignore, right?
The
No,
problem
the problem
is
is the
it's a
4
nice
not
random
being inside a let.
expression.
No. The problem is that the
It's
for
an expression.
return a unit, and we cannot just throw a unit like this.
I think if you do this, let me see. If you do this,
No, because that also returns a unit. That
oh,
unit
that's
to
also
unit.
returns a unit. Yes, that's right.
But here it could be any expression lambs. Doesn't need to be a for. It just needs to return a unit, and we would have problem, I guess. Well, that's like our main function, right? So we first want to do that. Then
That doesn't work in F sharp, by the way. I think.
what?
Let deconstructing like with a unit.
I think it does.
Let me try.
We just don't have a use case for it because he ignores units.
Units, FSI. Let.
But Lemus, okay. Oh no, we need another for, right? So
Yeah, we need another 4.
so J, I guess. By the way, is this inclusive,
Yeah,
Magenta?
it works.
Do you know that?
Yeah, it works. What do you mean?
Do you know if this is
Enclosed?
inclusive?
Inclusive.
Like,
Yeah,
oh,
if
Like
the
a
width.
4 with another 4. Yeah.
oh, then we need like -1, right?
I think. Let me see.
Don't we have a modifier? It should be like not
Dude,
inclusive.
can you open the OCaml REPL?
Sure. And here's a nice part, Magenta. I can just.
Oh. Oh, that's.
Oh,
good.
I can't?
I'll probably need easy.
Yeah, now I can.
So can I type here? No, I can't.
Oh, I think I can give you.
Anyway, just
Wait, I think
yeah,
I
you
can
can
give
just type in.
Okay, what should I type?
Just the 4. Try like 4 e equals 0 to 10.
Oh,
And let's see. And print.
no, man, we can just do it better. We can just not 200. That's read it. That's why. Let's do it like then. We can just execute the thing
Okay,
also.
Yeah, execute the module, right?
Like that way. Like we have easy X. You like put in an environment that you will install and shit, and then you call it by the name that you have here on public name. So you can just do that. Holy fuck. Okay. Let's do it here. Alright. And can we do that? Nope. Let's just comment that then.
Why can't you do that?
I don't know. But yeah,
assigning
it is.
again the E, I think, right? Oh no, you're using J. Yeah, I don't know.
Oh, I think that was because of this here. Here we would need. Yeah, this needs to return unit. So that would be like this.
Oh, okay, yeah.
Like in. And then I can get this expression here, I guess. Yeah.
Yeah.
So yeah, it is inclusive. So we do need the -1. I would suspect that we have something instead of 2.
Running. Did you run?
Yeah, it's here.
What? I can't see anything.
Really?
I think on Discord I can, but like on Visual Studio I cannot. Oh, you open a new terminal, that's why.
Oh.
I just can see one of them.
But yeah, it is working and it is inclusive. I would suspect that we have a keyword for turning it in not inclusive, but it's good for now. So let me get rid of this. So Lemus, we have the coordinates. What do you want to do with them right now?
Okay, so the next thing that we need to do is to the guy maps. Now it starts the crazy map stuff.
Wait, but this is like this, right? He first goes to the
Yeah, it kind of really doesn't matter because it's a square. So
Not that it's a square, but doesn't matter the order that we traverse the plane, right?
yeah, that doesn't matter.
Oh, okay.
Okay, so now the guy does the crazy map stuff. So he's mapping the iterators from 0 to the width of the plane to minus I don't know,
Wait,
minus 20.
are you sharing on Discord?
I'm gonna just send this link, man, and then you open there.
Let me just do something first because
Open on Discord there.
we need a complex number, right? Let's call it like just
We
C for
need
now.
a complex number.
Then we want like complex number dot create, and then we only have for floats, right? For now, at least.
Yes.
Then yeah, we actually have to
Open
do
the link that I sent you on Discord.
wait just a moment. So float of in I.
Yeah, that's not gonna work.
Wait a bit. Okay. Why is that not going to work?
Because I and J are too huge.
Too huge.
Oh, right. It's gonna overflow. Yeah.
What do you mean?
Just open the link, man.
Yeah.
I think it's easier.
By the way, your voice is a bit strange.
Weird?
Yeah, it's a little like low pitch.
Like robot.
I
Yeah,
didn't change
Roblox.
anything about it.
Okay, this here.
Yeah.
Yeah, but that's right, man. Like we cannot cast the thing.
Okay, so 30 to 31. This is the first thing that you should do in the loop.
Wait, give me the line. 30 to
30 and 31. Mean slider is basically a slider that he added in the application that goes from...
it's the dynamic value.
Yeah, minus 2.5 to 2.5, basically.
Yeah, but we want that.
So he's basically
map again in JavaScript.
Yeah, so I can try. So because then Nathan can check if I learn it or
That's
not.
slicing
No,
the
wait,
thing,
wait,
like
wait, folks.
range. Like
No, wait a bit. Why are, let me see, mean slider.
Because I remember that crazy function, like a range, I think, in NumPy.
Lemos. Why do we need to map that to like smaller values?
Why? I don't remember right now. I don't remember, man. Honestly. I would do it regardless, just to see if it works. But what is going on there, Mageta, is basically he's mapping the interval of values from like 0 to 200. He's mapping that to a smaller, like, it's basically like a normalization process.
Yeah, if I remember correctly, the way you do in JavaScript, you multiply, no, not that. Like, I guess you multiply by a number to change the magnitude, and then you, like, do a floor or something.
Yeah, again.
So it is basically changing the scale from 0 to 200 to minus 2.5 to 2.5.
Wait, we can do like that. Generate random number.
No, but we don't want. I don't know if we want to create a random number.
No, it's not really a random number. It's because they use that mapping in the function to create that.
Oh yeah, yes, to set the intervals, right?
Yeah. So min and max, they get a number, then they what?
I think this is to make sure that the random number is inside the min and the max.
Yeah, but I was expecting the floor thing, and I think they are substituting by these. Oh no! Oh, here, floor. Wait, I don't want to get in here. So math.floor. But
wait, what is the example one? Go to example one again. Example one. The example will generate an integer random number between 1 and 5. Yeah, they all do the same thing, man.
No, but here it's an int, I guess. The first
one... that's the thing. It's an int. You're right.
But I don't know why they are doing this way. Isn't just too much multiply by a specific number?
Why? Wait. But why are we interested in random numbers right now? That's the thing that I'm not getting.
You see, the math.random, it generates like a number between 0 and 1. Right? Then you can multiply that by 100. You see? And and then do a floor, and then you will get a number between like 0 and 100.
Yeah, I see, but why we want that?
Because that's a mapping. It went from 0 to 1, from 0 to 100. That's the mapping that the guy is doing. That's why I wanted to take a look.
No, I don't get it, because I think the guy is not doing that. Okay, he's just changing the scale.
So, yeah, that's what the guy is doing. So, we have a n, we have a mean, a max, like of the original, right? That's called.
Yeah, this is the map you're talking about, right?
Yeah, that's the map.
Yeah.
And then we have like the mean of the target, right?
Yes.
And we have the max of the target.
Yes.
So.
That's exactly what he's doing in my eyes.
Okay, I see. Because that here, it's fixed on this case of random. Because random has these parameters of generating a number between 0 and 1. So that's the mean and the max of the thing. See?
No, I still don't see where the random comes in.
Man, the random doesn't matter. It's just that for doing that function, he is mapping. Like a fixed version of mapping. A less generic version of a mapping.
Yeah, but let's just stick with the one that he's using. I think it's even easier to understand.
No, but you don't understand. You see that map here that he has? That's not from JavaScript.
Oh. This is not from JavaScript.
No, it is not.
Ah, now I see.
Yeah, this is another function, right? Yeah, maps in JavaScript, they think they are postfix. Like they're
not postfix, they are a method.
Oh, so now I understand why you're interested in the random stuff.
Wait, oh man. So okay, like each. Okay, I see how that.
But they don't change the value. They return a new one.
Yes,
but in JavaScript, like a bunch of things. I'm not sure if everything, but a bunch of things are object in JavaScript. If you have the primitive types, when you are calling a method on it, they do it a wrapper, and then you have methods in it.
Anyway, guys, I think we should continue. So this 30 to 31, he's basically doing a normalization process with the A and B. Then 33 and 34, he's saving the original values because we're going to use it later. The 36, he's initializing a counter with the 0 because this is the criteria that he's using for conversions. He's using
the threshold and also the color, right? Depending on.
Yeah, his color. He's not applying any color or any color methodology in this case. But anyway.
He is like he's like shadows of gray, right?
No, it's only I think 2 shadows of gray.
No, it's only 1. Like if you take a look on that, those are probably like RGB, and he's using the same value. Therefore, that's great.
But what are the possible values that bright can be?
Oh, okay, yeah, they
only
are
2, I think. But that's just a guess.
Okay. Right.
What matters is the while loop. The while loop, lines 39 and 40, he's doing the square of the complex number, but he's doing that by hand. So he's creating new variables called AA and BB for doing the thing. And then he's redefining A and B with the new values plus the past values. So plus CA and plus CB. And if we reach a certain criteria that I actually don't even remember how he got to this criteria, you break the loop.
The threshold is arbitrary one.
No, but there's 2 thresholds, man. The first one is the 100 iterations, and the second one is the if in line 43.
If line
43.
43.
So if you reach this condition, you're gonna break even before reaching the maximal iterations.
I don't remember why is that.
I also don't remember. But the matter of the fact is, this is the loop that we need to replicate. From line 30 to line 47. I think if we get this ongoing, we're gonna be in a very good shape.
Hey, but we don't really need that, I guess. I don't think we do, because that's only...
I think we do.
I think that the only thing this is doing is, by then we already know it, then we will break sooner. But you see that this has the same... yeah, I don't know that he has the same effect, because he might as well achieve that and still go to max iterations. Yeah, I don't know.
No, if you achieve the if, you're not gonna go through the max iterations.
No, what I mean is, if I didn't have the if, I could have something that matched these conditions and still break the threshold if I didn't have the if.
Yeah, exactly.
What I mean is, I don't know if this is guaranteeing that if matches here, it's because we'll never surpass the iterations.
I think that the result implies that yes, because the result has different colors, man, and the only way to differentiate the colors.
Wait, isn't that the blow up? Oh, that's the blow up, isn't it?
What do you mean by the blow up?
So if it did this, then it converged, right?
Yes.
So this is the blow up.
Oh, so this is when it starts going crazy wild.
Yeah, and as soon as you went there, then you change the bright, right? Because see.
Yes.
Oh yeah, see here, bright is N. Oh yeah. Oh, nice. That's the blow up. But
yeah,
man,
okay.
Let's go back to the OCaml code, and you can like guide me through it.
Okay, so the first question is, we would be doing the normalization or not?
I'm not sure if we need to, but it would be good, right? Because we could tweak that.
But yeah, we could tweak later. Okay, so now we need to do a normalization. We need to change. We need to create another lets that picks I and J, and basically readjust the scale of them.
That is a thing, because here he's using a mapping function, right? And then he's passing the current range, right?
But not the current. This is always fixed, right? The 0 and max iterations.
No. What I mean, the current is the n is a value that go from 0 to max iterations.
Yes.
That's what I mean. Like, that's the current range, you see?
Yes.
And that's the range that he wants. Instead of doing that generic function that I don't know how to do it, we could just use these, because I might know how to do this.
Okay.
But I'm not sure. Like, do you guys have an idea on how to do this for sure? Or a better idea on how to do it? Oh, I think it's actually called, as you said, like normalization. And we have a formula for it. Is that the same thing that we are talking about? Or not? Maybe not.
Wait.
Normalization.
Maybe yes, because this is not this formula zi equals xi. I think this is a normalized version of each element, and I think that the map is doing for all of them. So maybe they are equivalent.
Not sure what you mean by all of them, because that's definitely not iterating to something.
Wait, can we see the implementation of this map?
Let's try.
There's a bunch of them.
Yeah, presenting 9 files. Like, how do we know which one is the one? Star sketch.
That's a good question, by the way.
Oh, not reference, definitions. So can we even go to file? Oh, we actually can. Okay, that's not the map that we want. That's an actual map for a matrix.
Okay.
That's the one we like, but not the one we want. Wait, why can't I? Oh, here. Oh, we have here matrix, 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 P5. That might be the... No, that's a callback. That's not what we want. Also a callback, 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 callback.
I think we shouldn't judge by the names. I think we kind of have to...
No, man. Callback is a function. Like, no one is... that dumb to name these and be a number.
Man, you are totally overestimating people.
Yeah, you're gonna bite your lip one day.
Oh, he's so big that he cannot actually render the thing, man.
Yeah, search for map, do a Ctrl F and just go. 500 matches? What about that?
Wait. This has a callback. I don't want that. Function map. No. No.
What a boss.
No. I don't think so. Holy fuck, I don't know where we have this. Normalize. Range of number in JavaScript. Man, and like, wait, what is the link? Here. And that's the thing. He's not importing anything, right?
No, but I know he is. But not here.
Oh, okay, I see.
If you go to P5, there's another file called index.
Yeah.
And
so
in there,
basically,
he's getting something in the lib. I think in line 4 or something like that.
Yeah, that's the thing. He's not using JavaScript modules. That's so that's P5. That version should be more specific.
We ended by searching JavaScript libraries. The dream of Magita, man.
Oh yeah, and we need to see its implementation.
I'm not looking to the screen, but
too heretical, right?
Yeah, I'm just hearing you. I'm drawing plots in PlanTML.
Oh, learning stewards follower website. Learning get started over reference. I think that's what we want. Reference. Oh, that's a nice site. We want map, right?
Yes.
It's
gonna be a 7,000 versions of map.
Nope.
Oh, this is the one.
Yep.
Okay, so.
Wait. Oh,
that's
okay.
exactly what we want, man.
Okay, but now we need to do like
no.
P5, GitHub.
That sucks.
What exactly?
No, you're gonna have to install it to read the source code. Is that what you're talking about?
Not install it, but I.
Oh, you're gonna open the. Oh, yeah, that makes sense.
Well, we cannot just use JavaScript in OCaml, right?
Yeah, no, but I thought you would. Oh, npm install.
F# without documentation, the dude doesn't go to the source code.
Man, I don't know what Lemus' problem is, man. He was working with that for a bunch of months. Like, I would expect from him that the source code would be the first idea.
Yeah, you don't go to the documentation because it doesn't exist.
Why would you have a documentation if you have the source code?
Because you can have bad source code. That's the reason. And that's obvious.
You're just messing. Just messing. Map. Oh, it's kind of organized.
Kind of.
It's good enough.
Utilities. It has a utilities folders. It's the best.
Yeah, then it's a bad.
Ever made.
Yeah, then it's a bad library. So nothing map.
It has Nathan's seal of approval.
Oh look, they have a bunch of documentation like map, but it's because we want the implementation, right? That's.
Yeah, we want the implementation, man.
Map. Holy fuck. What is the map, man? It is not. He's not using like a method, right? Or as I saw. Let me see. .map. That's weird. Is that the one? It is not, right? It is. Start, stop, start to, stop to, and within bounds. New vol. Man, I think that might be the one. Normalization. Oh yeah, this doesn't care about the... Oh, okay, he cares about the current ones, but he always maps to 0, 1. Yeah, I think that's the one, Lemos. What do you think?
Wait, no, isn't that there the implementation? That
No.
it's new val. We just need to do implement new val.
Yeah, here he's like doing additional checks, right? Start
Yes.
to... No, not... No, that's... Wait.
Can you go back to that Stack Overflow post that you found about normalization? So it's value minus min is divided by max minus min. Okay, go back there. So it's the value minus min divided by max minus min.
But see, here we are also using like constraints, you see?
No, but this is just for error checking. If you try to throw.
No, not really, because you have like two cases. And the first case, it's the normal one. It's normal that they start, it's less than it stop. So that's not the error case. That's the normal case. And actually he's just inverting, see? But yeah, I think constraint is important. Let's take a look on it.
I think we can finish up for today, man. Also.
Yeah, it took a long time.
Yeah, but we did.
Huh?
I'm kind of regretting the double for loops there, by the way.
Why?
That's ugly.
It's ugly as hell. I told you all.
I wouldn't say it's beautiful, but it is the best thing for the use case, man.
I don't know, man. It doesn't feel like.
Doesn't feel like it. I also agree.
Man, okay, you could implement range. If you implemented range...
Yeah, that's what I was thinking. Like, why you're trying to see what the function does, right?
Huh?
What are you trying to see on this JavaScript garbage?
How to normalize numbers. But that's not the range that we are talking about in the for.
Let's think what the function does. Like, if simulate some inputs for me. Can you do that?
Okay, we receive n. And n...
Don't use Studio, why are you doing that?
Okay. Okay, so map of n. N is a number that it can be as low as start 1, and it can go as high as stop 1. And we want to map that to something. It goes to at least start 2, and it goes until stop 2. That's what we want to do.
Okay, and simulate an input, like input output. What it happens?
If we have like 0 and 100, then the thing goes into the middle, right? Let's say that it's 50. I don't know. And we want to go from 0 to 1, then it's 0.5.
Okay, so you're gonna like basically divide the element by the quantity you want.
I don't know the implementation.
Let me think. Okay,
But that's the thing. We have the implementation here, right? And
yeah, we can try doing it. I don't think it is that difficult because we just defined the...
Like, here is the constraint. Oh, is the constraint just like a cap? Like, don't pass this? Maybe.
Let's do this another time, man. It's already almost 10.
So let's wrap up here.
Yeah, I need to make a presentation now.
Oh, yeah. So okay, I will stop streaming.